Here on Earth, we enjoy rather stable temperatures. The highest temperature ever recorded on Earth was 136 degrees Fahrenheit, that is 58 degrees Celsius, in the Libyan desert. The coldest temperature ever measured was minus 126 degrees Fahrenheit, that is minus 88 degrees Celsius, at Vostok Station in Antarctica. Although temperatures can fluctuate widely relative to most of the universe, the Earth is exceedingly warm. If we talk about our solar system, then the hottest planet is Venus, with an average temperature of 464 degrees Celsius. The coldest planet in the solar system is the dwarf planet Pluto, with an average temperature of minus 225 degrees Celsius. The Oort cloud is at once considered to be the most distant region of our solar system by NASA, but also beyond our solar system. This lack of clarity means it is sometimes regarded as part of the solar system and at others defined as the boundary between our solar system and interstellar space. According to Northwestern University in Illinois, temperatures in the Oort cloud could be as cold as 5 kelvins, that is minus 450.67 degrees Fahrenheit or minus 268.15 degrees Celsius, which would be far colder than any temperature found on our solar system. The coldest known natural place in the universe is the Boomerang Nebula, which lies in the Centaurus constellation, about 5,000 light years from Earth. Its average temperature is minus 272 degrees Celsius, about 1 Kelvin, according to the European Space Agency. However, scientists have artificially created temperatures that are lower than those that occur naturally on Earth, in the solar system, or even in the Oort cloud. Last year, a team of German researchers broke the record for the coldest temperature reached in a laboratory, a chilling minus 459.67 degrees Fahrenheit, that is minus 273.15 degrees Celsius, which they achieved by dropping magnetized gas 393 feet, that is 120 meters down a tower. But when we talk about the average temperature of the universe, we wonder how scientists measure it. What is the average temperature of the universe? Hi, this is Sudhir Talati, and in today's video, we are talking about how cold is the universe. Most of the universe is empty space, where temperatures are extremely cold. Furthermore, since space is expanding and most galaxies are speeding away from each other, the overall temperature of the universe is only getting colder. Temperatures in space will obviously vary, depending on where you are. Planets and stars will be significantly warmer than empty space, so measuring the average temperature of the universe seems like a difficult task. As you learn in science class, an object may exchange heat with its environment in 3 different ways: conduction, convection, and radiation. In space, the first 2 are out because there is nothing to conduct heat or to convect heat. What remains is radiation. So if the thermometer, say, was originally at room temperature, it will start to radiate that heat out into empty space. But will it receive any heat in the form of radiation? Of course it will. If that thermometer is in the vicinity of the Earth, it will receive plenty of sunlight. It will also get a fair amount of heat from the Earth itself. So don't be surprised if you see the temperature of the thermometer soar. But what if you take that thermometer into really deep space? Say one of those incredible voids in between clusters of galaxies that are so far from everything that if you found yourself there, you'd see nothing but pitch black space, as even the nearest galaxy is too far away, too faint for the human eye to see. Well, the thermometer will start to cool, radiating away its residual heat. It will cool all the way down and show you some temperature. But you already know that with today's technology, we cannot go so far in deep space to measure the temperature. But thankfully, there is a rather simple way of determining the average temperature of space. To do so, astronomers measure the temperature of what's called the cosmic microwave background radiation, that is the CMBR. Cosmic microwave background radiation, or CMBR, was discovered by 2 astronomers Penzias and Wilson in 1964, practically by accident. They were experimenting with the Homelhorn antenna. They observed a rather uniform hum emerging from all directions from the sky. To eliminate errors and possibilities, they even removed some pigeons from the vicinity of the antenna. After thorough observations, it was confirmed that these hums did originate from outer space. CMBR is radiation which fills the observable universe and is detectable in all directions. This is because CMBR was created shortly after the Big Bang. CMBR falls in the microwave side of the spectrum and is therefore undetectable to the unaided eye. To understand why CMBR formed, we can rewind all the way back to when the universe was just 300,000 years old. Following the Big Bang, the temperature of the universe was very high and practically everything existed in a plasma soup. All hydrogen atoms remained in an ionized state until the universe cooled down to about 3000 Kelvin. Once the temperatures were suitable, meaning below 3000 Kelvin, electrons and protons were capable of forming hydrogen atoms. A free electron and a free proton forming a hydrogen atom releases a photon. These photons are continuously traveling in all the directions in the universe, from Big Bang till now, what we see as CMBR today. The CMBR is composed of the radiation left over from the Big Bang, and the radiation is fairly uniform across the early universe. By measuring the temperature of the CMBR using various experiments, astronomers can get a rough estimate of how cold the universe truly is, and it turns out that it is indeed very cold. The average temperature of the universe is 2.725 Kelvin, which is equivalent to minus 454.7 degrees Fahrenheit, that is minus 270 degrees Celsius. The universe's temperature is less than 3 degrees above absolute zero, which is as low as temperatures can physically get. Although the temperature of space is near absolute zero, the universe itself will never actually reach that temperature. Even after the last stars have burned out, the universe will continue to emit at least some forms of radiation, which will ensure that the overall temperature of space never reaches the absolute coldest temperature possible. If you enjoyed this video, please like and subscribe to my channel. This is the fuel for me to make such informative content like this. Thank you for watching.